Hello everyone, I am Subhrian. Today we are going to see about Amdhal's law, the limit of parallel computing performance. What is Amdhal's law? Amdhal's law states that the maximum improvement in the system performance is limited by the portion of the system that cannot be improved, which is the sequential part of the program. It was proposed by John Amdahl in 1967. The key idea is speed up depends on how much of the program can be actually parallelized. Like even with unlimited processors, the serial pods create a hard ceiling on performance like serial and parallel execution. Every program has two pods. One must run in order, another one running at the same time. Serial. One task finishes, then the next task begins. Cannot be done in parallel. In parallel, all tasks run at the same time, which is faster but limited by the serial part. Why Amdahl's law important? It helps to predict the performance. Use a formula to estimate speed up before building an expensive hardware. It reveals the real bottleneck. The serial part is what limits the speed, not the number of processor. It guides the hardware decisions, like helps the engineer decide how many processors are actually worth adding. Useful in system parallel system design, a standard tool in parallel computing, compiler and architecture benchmarking. The formula to calculate speed up equal to 1 divided by 1 minus p plus p by n, where p is the fraction of the program that can run in parallel. N is the number of processes, 1 minus p, the serial fraction. This part cannot be parallelized. It is the bottleneck. Speed up. How many times faster the program runs with n processor versus one processor. Let us see a worked example. Given that the p equal to 0.8, that is 80% of the program can be parallelized. N equal to 4 processor. Substitute the values in the given formula. We get 2.5. From the result, we know that even with the 4 processor, the program is only 2.5 times faster, not 4 times, because the serial part 20% is holding it back. Like we see the graph versus speed up versus processor. The graph shows that the speed increases quickly at first, then it flattens. Higher the P is better parallelism. Serial part sets a hard limit on that. Even P equal to 0.95 cannot scale infinitely. Like we see the advantages of Amdahl's law. It helps to predict the performance. Before building a hardware, you can estimate the speed up just by using P and N. It is easy to understand. Just two variables, P, the parallel fraction, and N, the number of processes. Useful in parallel system design. Guides architects in choosing the right process count for a workload. Reveals the real limiting factor. Makes clear that the serial portion, not processor count, is the bottleneck. Limitations like assume fixed workload. Amdahl's law does not consider increasing the problem size when you add more processor. It ignores the communication overhead. In real systems, process spends extra time in sending and receiving the data. This delay is not accounted for this in the formula. Next, not actual practical. The value of P, the parallel fraction, is hard to measure accurately in real programs. It changes depending on the workload. Like in real world applications, it is used in multi-core CPU design. Like Intel, AMD use Amdahl's law to find the right number of CPU cores. Compiler optimization. Compilers identify which core sections are worth auto-parallelizing. Cloud computing helps architects choose the correct number of servers per workload. Next, using big data, map reduce job efficiency is estimated using parallelism principles. Next, it is used in AI and ML training. Serial pre-processing, step limit, how fast models can train on GPUs and graphics. Evaluating GPU speed up for simulations, rendering, and physics. Conclusion. From that, we know that Amdhal's law shows that performance improvement is limited by the sequential processing of the program. Even with unlimited processors, the speed up cannot go beyond a certain limit. A program has a serial port and a parallel port. More processor helps, but only up to a point. The serial port creates a hard ceiling on the speed up. Okay, this is all about Amdahl's law. I hope you all understand. Thank you.